Today we're going to be looking at creating tree diagrams a little bit more in depth and using that as a way to count possible outcomes in order to apply it to probability. We're going to start with a couple movies.
How many different ways can a red, blue, and green marble be pulled from a bag? In this lesson, you will learn how to find the probability of compound events by creating a tree diagram. Let's review how we can list all the possibilities in a situation. And one example question might be, list all the possible ways that Chris, Aaron, and Sam can place in the upcoming race. One way we can do that is by creating an organized list. So we use parentheses to represent each outcome, and one way that we can place is Chris, then Aaron, and then Sam. Or Chris could still come in first, but then Sam and Aaron switch places. Then we move on and act like Aaron would get first, and then Chris and Sam, and then switch those two places again. And then lastly, Sam could come in first, and we switch up those places. So this lists all the possible ways that Chris, Aaron, and Sam could place in the upcoming race. And organized lists are a really great way to just kind of organize our thoughts and put everything down and list all the possible combinations. And we're assuming that no other factors like skill or stamina are coming into play. Now we can quickly see that there's 6 possible outcomes, and then we can find the probability of a certain placing. So when we're making an organized list, like one here where it's asking you to show all the possible arrangements of the letters T, A, M, E, one common mistake that students can make is get lost and confused trying to figure out at which point in the list we are. So this would be an example of how we would go about creating that organized list. And as you can see, there's a lot of ways that we can organize the letters T, A, M, E. And I'm listing all those possible ways, but a lot of students will say, this is crazy, and I'm really confused at which point I was, or you might list something twice and not even realize it. So that's a common mistake that students can often make, and we're going to show a different way to organize your thoughts in this lesson. So the question at the beginning of this video asked, how many different ways can a red, blue, and green marble be pulled from a bag? And we're going to show all the possible ways by creating a tree diagram. And you create tree diagrams by first showing the roots and all the possible choices in the first pull from the bag. So our first possible choices would be picking a red marble, a green one, and then a blue marble. So these are all the possible outcomes in the first pull of the bag. So now we just create more leaves in our tree diagram off denoting the second pull from the bag. So for example, if we picked red first, then in the second pull from the bag, we could either pick blue or green marble. And if we pick green first, we could either pick a blue or red, and the same thing for blue. If we pick blue first, then what's left is a green or red marble. So now then we just have more leaves coming off of our tree diagram, listing the last marble that's left, or the last one that we would pull from the bag. So if we picked green first and then blue, then what's left over is, if we picked red first and then blue, then what's left over is green, and so on. You can do that for the rest. And you're just showing the tree diagram, listing all the possible outcomes in an organized way. So after we've created our tree diagram, we can see that there's 1, 2, 3, 4, 5, 6 possible ways to pull a red, green, and blue marble from a bag. And the question might ask, what is the probability of getting green, blue, and red marbles in that order from the bag? So we would denote that as the probability P of green, blue, and then red. So if we're trying to find that order, we're looking for that outcome, and I'm highlighting that one there. This is the only outcome where we get green first, then blue, and then red. So then our probability of getting that order would be 1/6, because there were 6 possible ways to pull the marbles from the bags, and one of them resulted in the one that we were looking for. In this lesson, you have learned how to find the probability of compound events by creating a tree diagram.
Okay, now we're going to take a look at Khan Academy and see what Sal Khan has to say about tree diagrams.
Let's say that I've just won some type of contest at a car dealership, and they're going to give me a brand new car. And in deciding which car they give me, they're first going to randomly select the engine type. So the engine will come in two different varieties. It'll either be a four-cylinder engine or a six-cylinder engine. And they're literally just going to flip a fair coin to decide whether I get a four-cylinder engine or a six-cylinder engine. Then they're going to pick the color. And there's four different colors that the cars come in. So I'll write color in a neutral color. So you could get a red car. That's not red. Do that in an actual red color, closer to red. You could get a red car. You could get a blue car. You could get a green car. You could get a green car. Or you could get a white car. And once again, they're going to randomly, let's say, just pick, they're going to have red, blue, green, and white in little slips of paper in a bowl, and they're just going to pick one of them out. So all of these are equally likely. So given this, that they're just going to flip a coin to pick the engine, and they're also going to, that all of these, the color is all equally likely, I want to think about the probability of getting a six-cylinder white car. The probability of getting a six-cylinder white car. So I encourage you to pause the video and think about it on your own. Well, one way to think about this is, well, what are all of the equally likely possible outcomes? And then which of those match a six-cylinder white car? Well, first we could think about the engine decision. We're either going to get a four-cylinder engine. So the first decision is the engine. You could view it that way. You're going to get a four-cylinder engine, or you're going to get a six-cylinder engine. Now, if you got a four-cylinder engine, you're either going to get red, blue, green, or white. And if you've got a six-cylinder engine, once again, you're either going to get red, blue, I think you see where this is going, that's not blue, red, blue, green, or white. So how many possible outcomes are there? You could just count. You could kind of say the leaves of this tree diagram. 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. And that makes sense. You have two possible engines times four possible colors. 2 times 4. You see that right here. One group of 4, two groups of 4. So this outcome right here is a four-cylinder blue car. And this outcome over here is a six-cylinder green car. So there's 8 equally possible outcomes, and which outcome matches the one that we, I guess, are hoping for, the white six-cylinder car? Well, that's this one right over here. It's one of 8 equally likely events, so we have a 1/8 probability. Now, this wasn't the only way that we could have drawn the T diagram. We could have thought about color as the first row of this tree. So we could have said, look, we're either going to get a, let me do it down here so I have a little more space. We're either going to get a red, a blue, it's not blue, changing colors is the hard part, a blue, a green, or a white car, and then for each of those colors, I'm either going to get a four-cylinder or a six-cylinder engine. So it's either going to be 4 or 6, either going to be 4 or 6, either going to be 4 or 6, either going to be 4 or 6. This would be another way of drawing a tree diagram to represent all of the outcomes. So what is this outcome right over here? This is a six-cylinder red car. This is a four-cylinder blue car right over here. Which is the one that we care about? A white six-cylinder car? That's this outcome right over here. Once again, you see you have 8 equally likely outcomes. And that happens because you have 4 possible colors. And for each of those 4 possible colors, you have 2 different engine types.
All right, thank you, Sal. So for our next, let's do another example. It's your birthday, and you get to choose a cake. You have a round or rectangular cake. The flavor can be vanilla chocolate or lemon, and the icing can be buttercream, chocolate, or cream cheese. How many cakes are likely or possible to make? So we could start with, and of course I don't even usually start the branches. I notice that they all start from like one location for the first branch. I usually just write out the words of what they are. So I would start with round or rectangle. That's the shape of the cake, right? First thing we have to choose. Then we have to choose the flavor. And so from each of these shapes, we could have that we have a vanilla or a chocolate or lemon. So again, vanilla, chocolate, or lemon. And then the icing can be, I'm going to start abbreviating here, buttercream, chocolate, or cream cheese. So buttercream, oops, chocolate, cream cheese, and buttercream, chocolate, cream cheese. Same for here. Buttercream, chocolate, cream cheese, buttercream, chocolate, cream cheese, and then finally, all right, so counting the last row of our tree, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 different cakes that are possible for our birthday. Now, a lot of the tree diagrams today were kind of in this horizontal fashion. Yesterday they were all in the vertical fashion. It really does not matter. It could be a matter of room on your paper or scratch paper, but it shouldn't matter. And again, the order isn't necessarily as important as it is in making sure that you have the right number of choices for each different event that's happening. All right. And this is Kleinman out.